Hey everyone, welcome to my first official video of the channel. I did a short video before this to introduce myself, but this will be the first one where I'm diving into a particular subject. So let's get to it. So NASA has a satellite called the Deep Space Climate Observatory, or DSCOVR for short. They do love their acronyms. Anyway, back in 2015 and 2016, DSCOVR filmed the moon transiting in front of the Earth. So let's take a look at those videos. I think it's pretty cool, but of course science deniers had a cow when they saw it, calling it a fake. And just going through the comment section on this video, I found plenty of naysayers questioning the validity of it. So here's some of the more trollish comments. Yep, that's 260,000 miles apart for sure. NASA CGI fakery. Oh my God, so fake. Ha ha ha. If you're going to do a fake, at least make it follow the freaking models we've been taught. Oh my God. This has the moon in geosynchronous orbit with Earth, which it isn't, since the moon makes a complete orbit around the Earth every 27 days. Nonsense. Second, we have 0 satellites out that far from Earth, dummies. And there were some people that just honestly seemed to not understand what they were looking at. Why is the Earth bigger now than Apollo? If that's the ratio, then pictures from the, quote, moon landing should have the Earth as huge in the background. Why does the Earth look so huge in this video? I can kind of understand why people have an issue with this. We're used to seeing images from the Apollo missions where the moon looks really huge in the foreground and the Earth looks relatively small in the distance. But how can the Earth look so drastically different in each situation? So I've set up a demonstration to show exactly what's happening in this video. So let's take a look. So I'm going to use these, and I have the moon hanging from this PVC frame. So I'm going to be setting these up. Not only are they scaled to each other, but I'm going to set them up so that the moon is a scale distance away from the Earth. It's surprising like how far the moon actually is when you see them apart from each other. But I just wanted to get this shot so you can see how small the moon actually is compared to our Earth. And so I'm going to go ahead and move the moon out to where it should be for scale distance. It looks like it's really far in that last wide shot of me moving it. But in reality, the moon is 384,000 kilometers away from the Earth. And that translates to about 9.2 meters out at that scale. So it's a ways. And even going as fast as the Apollo rockets did back in the 60s and 70s, it still took them 3 days to get there. So it's a long ways. Even in this shot from where the camera is now, you can see like how small the Earth looks compared to the moon. In fact, they're almost kind of the same size on screen. So a lot of people are still probably asking like, exactly, so why does it look so big in that DSCOVR satellite video? So what's going on there is a thing called lens compression. And it's not so much about the lens, but the distance between the camera and the foreground subject and the ratio between all that and the background subject can alter the apparent relative sizes of the foreground and background subject. So if you're really close to a subject, like this camera is now, it'll make the background subject look really far away. And the farther away the camera is, the bigger the background subject is going to look compared to the foreground subject. Even though this distance here is not changing, your foreground and background subject aren't changing their sizes, they're not changing the distance apart. The only thing you're changing is how far away the camera is. That's it. I'll be taking a series of shots of this setup to hopefully compare the shots that we would have seen from the Apollo missions, like the one that Michael Collins took on his orbit of the Earth in the command module, showing the moon below him and the Earth, a little sliver in the distance, and a shot mimicking what Discover took, showing the Earth much larger on screen in comparison to the moon. So even in this shot, you can see the moon is starting to look bigger than the globe, relatively speaking. And that's just because I'm a little bit closer with a wide angle lens. And so the moon is just going to look really big. And this is kind of what people are expecting when they see Earth and moon in the same shot together because of the shots we get from Apollo. But you gotta keep in mind, all those shots, like even when Michael Collins was orbiting in the command module, and he's like just barely away from the surface of the moon on this, on this scale, it'd be, I forget the exact distance, but it would be pretty close. So he's like right on top of the moon. And so yeah, it's gonna look huge with the Earth being very small in the background. So I'm gonna take a shot with my cell phone to kind of, because it's a little, cell phone gets a little better focus when it's super close to something. So the next shot I'm going to do is from much farther away to mimic the scale distance of the Discover satellite. And you're going to see quite a difference in how these two objects appear to each other. And I'm not going to move them. The moon's going to stay right here. The globe's going to stay back there. Their distance is going to maintain that 9.2 meters apart. And the only thing I'm doing is changing where we're looking at them from. And you'll see a kind of an amazing difference in what happens. So this is the camera that's going to be mimicking the Discover satellite position relative to the Earth-Moon system. And Discover is nearly 1.5 million kilometers away from Earth. So it's out there. It's almost 4 times as far away from Earth as the moon is. So you can just kind of barely see it on the video here, but in the background is, against the black, is Earth with the moon kind of in front of it. It's very tiny from this spot because we're so far away. But at this scale, like I said earlier, the moon is about 9.2 meters away from the Earth. And at that same scale, Discover would be 35.3 meters away from the Earth. So it's, like I said, it's out there. So for this shot, I have my my SLR camera with a 200 millimeter lens. And even with this length lens, I'm still gonna have to crop in quite a bit to get the shot I want. But you're gonna see the effect from being so far away of the Earth looking huge, because from here, the moon and Earth are relatively close together now. Even though I haven't moved them, from where we are, that the ratio has changed drastically. Whereas before, we were very close to the moon, so the Earth was relatively far away. As you can see, like I said, the Earth now looks much bigger in comparison, even though I haven't changed either the position of the moon or the Earth, and that's due to that lens compression effect. So I'm going to take a series of shots now from first to last contact of its transit and do a simple animation kind of mimicking the transit that we see in the videos. One of those commenters said the DSCOVR video shows the moon in geosynchronous orbit around Earth, which would mean that the moon is going around the Earth once a day in lockstep with the Earth's rotation. Since we've demonstrated that the moon is much farther away from the Earth than it seems, that also means it's going much slower than it seems. In order to cover the distance from first to last contact, I had to move my scale moon 30 centimeters in its orbit. The moon is 9.36 meters from the axis of my globe. When you do the calculation for the circumference, the orbit of my scale moon is 58.81 meters. 30 centimeters of that nearly 60-meter orbit is only about 0.5% of its full orbit. The Earth, on the other hand, since we know this takes place over 5 hours, is rotating about 20% of a full rotation on its axis. So the Earth is actually going through 40 times more degrees of movement than the moon is. It's not even close to being geosynchronous. As another example of lens compression, I took some photographs of myself in a parking lot with a light pole in the background. In the first example, I'm about 30 paces away from the light pole. The camera is only about 8 paces away from me with a wide-angle lens. The light pole and I are almost the same relative height in the photo. In the second photo, the camera is now 75 paces away from me with a telephoto lens. I'm still 30 paces away from the light pole. That hasn't changed. But now the light pole looks much taller than me, and the only difference is the distance from the camera to me. This is a demonstration that anyone can do that clearly shows the effects of lens compression. You don't even need a camera. Just look at the relative size of two objects from near one of them, and then back up and see the relative size between those two objects change. Hopefully this helped you understand what you're seeing in the DSCOVR video. Nothing in that video contradicts anything we've been told about the size or distances of the Earth and the Moon. You just have to understand that the DSCOVR satellite is much farther away from the Earth than the Moon is. So the Earth is going to look relatively larger than it does in the Apollo images, where the moon and the camera are basically the same distance away from the Earth. So that'll wrap up this video. If you found it informative, give it a like, hit the subscribe button, and be sure to check out my next 2 videos where I'll be talking about eclipses. Thanks for watching.